Hi, I'm Kevin Deierling, the VP of Marketing with Mellanox Technologies. It's a great pleasure to be here, and the Mellanox guys in the front row here. So I'm going to talk about the power of 100 gig and a perfect storm for open networking, and also we'll have Netflix here to talk about what they're doing with 100 gig. So the perfect storm that we see with open networking is really a combination of three different changes that are happening, and we heard about many of them this morning in the keynote sessions. And the first one is a technology transition for Ethernet. And there's a thing called the 25 gig and 50 gig consortium. I'm actually going to be talking about 100 gig. I'll give a little background on that technology transition. At the same time that is happening, we see an open platform transition occurring. We call this Open Ethernet. OCP is really the classic group that's driving that. So with the Open Compute project, we've been involved since the earliest days. I'll talk about what we've done with OCP. But this whole concept of open platforms is really disrupting the traditional players that have closed proprietary platforms and changing the way technology is being delivered today. And the third piece that we see is really all these cloud and telco applications embracing both the new speeds and these new open platforms. And together with new software-defined infrastructure so that instead of running on custom-built hardware, you can run on a standard server with standard interconnects. Together, all three of these are combining to create a perfect storm that's going to disrupt the way that we've seen traditional markets with the incumbents there that are building closed platforms. So I'll talk about each of these three. So first of all, you may be hearing about 25 and 50 gig and 100 gig, and it's kind of interesting to understand where this came from. On your left there, it's Bob Metcalfe's Ether napkin. So it was the first Ethernet sketch that he made back in 1973 that said, hey, here's this idea for Ethernet. And that was at the lightning fast speeds of 1 megabit per second when that was first introduced with coax. I see some of Nathan's nodding his head here. He remembers it. So do I. I actually ran this when I was at Berkeley into the professor's office. But over the course of 30 years, we got to the point where we had 10 gigabit Ethernet. And so we advanced very quickly over those years. And even that wasn't enough. And if you go look at some of the servers today that Facebook's showing in their booth, they're using 40 gigabit. And if you look at it, the way they got to 40 gigabit is you striped 4 10 gigabit solutions together. You took 4 10 gig links and you got to this 40 gig. It's 4 by 10 gigabits per second. And even that wasn't fast enough, so we said, hey, let's go to 100 gig. And so now we have 4 by 25 gig. Last year at OCP, we introduced our ConnectX-4-based platform that went into the OCP cards at 100 gig. And it seemed really obvious that we should also, just the way we have 10 gig, we should have a 25 gig link, and we should have a 50 gig link. And it turned out that it didn't happen. Okay, it turned out it didn't happen. The IEEE actually looked at it. A bunch of people said, hey, should we have this 25 gig link and 50 gig links? And the IEEE said, no, we're not interested. It turns out the IEEE is not actually, it is a technical organization, but it's also a political organization that there's a lot of companies in that didn't want 25 and 50 gig to happen. And so together, a bunch of companies, there were 5 companies that formed this 25 gig consortium. It was Mellanox, Microsoft, Google, Broadcom, and Arista that formed this consortium. And we said, we're going to do it ourselves. And this is an example of the disruptive technologies that's happening. It's no longer these big companies that are controlling the IEEE that are saying, hey, you can't do that. We just went and did it. Okay, the industry can go do this. OCP is an example of things that we can just go do and really disrupt the industry. So that's where this 25 and 50 gig is coming from. Today, we say that 25 is the new 10. We don't see why people would deploy 10 gigabit today when you can get 25 gig, slightly more expensive, but a small price premium, 2.5x the performance. So why wouldn't you future-proof your network and go with 25 gig? We're also seeing 50 gig now, people moving from 40 to 50, and of course 100. So one of the reasons that's driving the adoption of these higher speed networks like 25, 50, and 100 is storage. Faster storage needs faster networks. And if you look at this graph here, it's showing what's called NVMe. This is the state-of-the-art non-volatile memory over PCI Express. And a single NVMe drive can actually saturate a 25 gig link. So we can saturate 25 gigabit Ethernet with a single NVMe drive. So if you're putting 10 gig into a system and you've got an NVMe flash drive in that system, then effectively you're throwing away 2/3 of the available bandwidth and performance of that NVMe drive. So really we see this is the OCP card that we introduced this week, the ConnectX-4 LX based. We made the contribution to the OCP organization, so the design both for our single host and our multi-host version of that goes into the Leopard. Those platforms have been contributed. We've also contributed a 50 gig version of this as well for multi-host and single host. So this is a key capability. We believe that this faster storage is driving the requirements for faster networks. You can see with just 3 NVMe drives, we can saturate a 100 gig link. Okay, so just 3 NVMe drives in a server, and you'll see later that some of these servers can certainly support a lot more than that and need the bandwidth. So these are the contributions we made here this week. These are some of the new things that we're introducing at OCP. So I talked about the 25 gigabit Ethernet NICs, the 50 gig, and the 50 gig multi-host. All of those have been contributed. The design specs, they're available. They're in consideration now for being accepted by the OCP organization. And on top of that, we also were showcasing this week our Spectrum switch. So we have an end-to-end portfolio of products, adapters, switches, cables, copper cables, silicon photonics cables, VCSEL-based multi-mode cables. And the other key thing that we announced yesterday was a CDN reference architecture that you'll hear a lot more from our friends here at Netflix. And so that's a content distribution network where we did the reference architecture and we published that. It's not exactly what Netflix has used in their data center because I think that's very customized for their use case, but it's a representative of what they're doing here. The other key thing that we introduced was something called Open Composable Network. And Open Composable Network is something important I'll talk about here in a second. The other key things that we did here was show all of these platforms in our booth. I invite you to come upstairs and go look at that. We're in booth B4. We have the Yosemite, which is a multi-host platform. They're also showing that in the Facebook booth. And this is where we can actually share a single NIC between 4 servers. So each of the servers looks at one NIC, and it thinks it's its own NIC. It doesn't realize that it's actually being shared by 4 other servers. And obviously, there's lots of cost and cabling expenses that you save when you can actually share a NIC between 4 separate host CPUs and servers. The other thing we're showing is the Leopard, which is the dual processor version of that. And then the Barrel Eye, which is a rack space-based server that's actually running the Open Power architecture. So this is a PowerPC, the IBM PowerPC-based CPU, again, running on the Open Power platform. So we're showing all of those in our booth. Exciting times. But probably the biggest announcement we made here this week is called Open Composable Networks. And I was really excited in the keynote this morning when the telco guys were talking and they said, what we need is composability. Okay, so we're talking about disaggregation of the servers. And really, you have to put it back together. If you take it all apart, you also need to put it back together. And that's the whole idea of open composability. And there's really 3 different elements to that. One of them is these open platforms. So we call it Open Ethernet platforms. And there, the real key is that you need your choice of network operating systems. So the other key announcement that we heard this morning from Microsoft is that they contributed Sonic into open source. So now we have the Microsoft network operating system, which is a Debian-based Linux operating system that's a switch operating system now that's been contributed to open source through the OCP organization. But on top of that, we were also showing the Cumulus networks, which we announced this week, is supporting our Spectrum switch. So Cumulus is a Linux-based network operating system that's running in our booth. Sonic is there. OpenSwitch. So OpenSwitch is the network operating system, open source from HPE. So Hewlett-Packard has also entered this market. We have our own network operating system that's running on our platform, and Metaswitch is another company that their network operating system is running on our Spectrum switches. So really this is the key. First element is these open platforms and open network operating systems. The other thing is, to make this easy, we need standard APIs. And again, you heard Microsoft this morning talking about SI. So SI is the switch abstraction interface. And what that means is that they write their operating system, in this case Sonic, to SI. And the underlying hardware is abstracted away. So they don't care whether it's a Mellanox piece of silicon inside of that or somebody else's silicon. They use the same commands, and they don't have to rewrite their network operating system. So what this means is you get very nimble in terms of not being locked in to a single vendor. And if one vendor executes and another one doesn't, you very quickly move to the best solution that's out there, the best hardware that's out there. The last piece, of course, is network automation. And we heard people talking about automation as a key. And again, we have a platform called Neo, which is our network orchestration package, and that interfaces as well with a whole bunch of different third-party tools for doing network orchestration and network automation. We published a blog today about our open composable networks. I encourage you to go to our website and you can read that. The other thing that I talked about was that we're going to compete at the hardware level, not by locking you into the vendor. And really, we think we have the best performance here. And I talked earlier today and gave some details about things like packet forwarding, microburst resilience, and fairness in the underlying hardware itself, in the ASIC that we're doing. And we develop our own ASICs. We get 10 to 15 times better microburst performance than our competition. And similarly with bandwidth allocation, but most importantly, we don't drop packets, okay? We do not drop packets. When we say we're full wire speed, that means we're full wire speed across all packet sizes, 64 bytes up to 9K jumbo frames. And so it's really important that when you're writing an application and you're running with switching infrastructure, that if something is wrong, it's not in the network. You know, if you have a congestion problem or there's something in your application that you're sending the data too fast, those are things that you should maybe have to think about and worry about, but not that somehow on the way through the network, some packets got dropped for unknown reasons. So we're really all about zero packet loss and predictable networks. Here's a comparison that we did. We published this today with what's called the Tolly report. This is showing us on the right that no matter what the packet size is, we don't drop packets. So this is our zero packet loss performance, whereas this is a Broadcom-based silicon. You can see that, you know, even at 200 bytes, they're dropping 20% of the packets that are going through the network. So we published this today on the Tolly report. So you can go to tollyreport.com. You can read this. There's lots more of interesting things in that report. But ultimately, 32 ports at 100 gigabits per second needs 4.76 billion packets per second. Anything less, and you're going to drop packets. And that's not something that your network should have to worry about. So the third element that I talked about that's really disrupting this market is now the adoption by the telco players of these open platforms. And we saw that this morning. And here are some of the companies that are involved here now with Open Compute Platform. Again, we did an announcement last week, or I guess it's 2 weeks ago now, at Mobile World Congress in Barcelona, where we showed with our 25 gig adapter, we were doing 33 million packets per second. Again, this is line rate, or near line rate, at 25 gigabit per second using DPDK. Previously, we did 100 gig last year at that conference. But really, I think the interesting thing here is there's already an early adopter that's showcasing how, in this environment, 100 gigabit Ethernet can be very important. And in a second here, I'll introduce Netflix, and they'll talk about their Open Connect appliance, the OCA, running at 100 gig. So with that, I put together a slide just to kind of show where this is positioned. You know, it's really, we published a reference architecture. Our reference architecture, naturally, is based on the end-to-end Mellanox products. What Scott's going to be talking about is primarily on the adapter side where they're using us. Obviously, it plays in with all of the different telco players here. Sanmina was who we based the reference architecture on, so it's actually a new ISIS box. You can come to our booth and see that. And with that, I'll introduce Scott Long from Netflix. There you go.
Thanks a lot, Kevin. So I'm here today to talk about just how great of a partnership we've had with Mellanox and how it's really allowed us to build a great product with Netflix. Netflix is about entertainment, it's about a great user experience, it's about great programming, and it's about helping you find great things to make yourself happy. The technology side of it is there because we need the technology in order to make that all happen. So, you might have heard a few weeks ago that a blog post about how everything was being transitioned to AWS. That was actually true for all of our server infrastructure, but when it comes to content delivery, that's the part that we need to control ourselves, and that's why we've created our own content delivery network. We've been in that business now for several years. We've started to grow worldwide, lots of infrastructure in both established and developing countries. But with that growth in geographic area, we've also had growth in demand, higher bitrate movies, more customers, just more viewing hours per customer. So we've had to grow both horizontally and vertically to do that. And for a long time, we were deploying 40 gigabit solutions in our data centers, trying to get 40 gigabits out to some of our partners. But a year ago, we sat asking ourselves, we need more than 40 gigabits. It's going to be 2 by 40. What's it going to be? And then suddenly 100 gigabit came along, and it solved the problem that we needed right when we needed it. I'm thrilled to say, as an engineer by training, I'm thrilled to say that with a single compute node and a Mellanox ConnectX-4, we can do 100 gigabits line rate from a single node, single socket Intel platform. And that's thanks to this fabulous collaboration we've had with Mellanox, their great driver set, and the collaboration we've had with all of our other partners, ISIS for building chassis, and all of our other component vendors. So what does that mean for everyone else? We like to lead the way. We like to help direct technology to our benefit, but we also want to have everyone else come along with us because it helps with scales of economy. It helps us not operate in a bubble that leads us in the wrong direction. We like to work with other people in the industry. So what we like to talk about is by building these compute nodes that are doing 100 gigabits, we're really about helping to maximize our footprint, get down the cost of serving bits, get down the cost of power, get down the cost of data center space, but still being able to grow. And we want other people to be looking at that too, because we don't want to be in competition for data center space. We want everyone to be able to come together and everyone to be able to deliver a great product. The other great thing about this architecture with ConnectX-4 and the fact that we can do 100 gigabits in a single node is that we don't have to do 100 gigabits in a single node. We can start out and we can start with our box that has NVMe, like Kevin said, a bunch of NVMe drives that can saturate 100 gigabits, but we can actually start out with 25 gigabits or 40 gigabits because that's the only interconnect that we have. But the fact that we've created this scalable solution with Mellanox means that when the infrastructure catches up and we're able to do more than 40 gigs, we can do 50 or we can do 100. It's a matter of relatively simple hardware change out. We don't have to forklift entire racks of equipment out and change them back to meet future demand. So it's really helped us create this not only vertically scalable product, but also this future-proof platform. So I blew through that really fast. I always tend to talk really fast, but yeah, so it's been a great partnership. We're not technically part of the OCP platform, but we do watch it very closely, and we're very happy that Mellanox and ISIS have come together to make this reference platform that they have on display upstairs. And if there's any questions about it, I'll be around afterwards, and I can talk both the hardware and the software side of it. So thank you.
My closing will be just to come see our demos. You can come see the new ISIS box in our booth. Scott didn't mention it, but we're actually running free BSD drivers on this, and we announced that as part of that. And I think there's a good partnership there with Netflix, and that's part of the secret sauce that's enabled us to deliver 100 gigabits per second on the single core CPU or single socket CPU. So encourage you to come out and look at all the different things we talked about, the open composable networks and all these new OCP cards, and then also the new ISIS platforms. Happy to take any questions as well. So. Do I have any comment about InfiniBand? InfiniBand is fantastic. We love InfiniBand. It's still a core business for us. It drives a lot of our revenues, certainly in the HPC space. Also in the enterprise space, you're using, I guarantee, if you surf the web today, you're using InfiniBand. There's data centers that are based entirely on InfiniBand. There's cloud data centers that are based on InfiniBand. It's still a great business. This business happens to be Ethernet related. We made a strategic decision as Mellanox 5 years ago, 6 years ago, to enter the Ethernet space. Today we have 90% market share in the Ethernet adapters above 10 gigabit per second. And so we love Ethernet. It's growing very fast for us, but we also love InfiniBand. Stay tuned. So the question was, how about 200 gigabit Ethernet? Stay tuned. You know, I think there's been a lot of discussions in the IEEE. I kind of bashed the IEEE. It's still a very important organization. We are very much involved. I hope there's nobody in the IEEE here. But 200 gigabit has been defined in the IEEE. There's different things. We participate at many levels: electrical, optical, single mode. You know, we have lots of things. There's PAM4 has been the technology, which is amplitude modulation, where you get 2 bits. So it's still sending at 25 gigabaud per second, but you're actually taking 4 of those lanes and you're sending 2 bits on every symbol, so you get to 200 gig. And stay tuned. It's coming. Nathan.
I'm confused about the AWS work that you've done and the content delivery network that you're using with Mellanox. Can you help me understand that a little bit better?
Yeah, so everything that you see with Netflix before you hit play on a movie comes from AWS. All of our back-end billing and business logic, the website, the authentication comes from AWS. It's when you actually hit play that you go over to our Open Connect network and everything streams off of that.
So how much hardware is involved in the CDN versus the AWS stuff?
AWS is fantastic for us because it's very elastic platform. Sometimes we need a lot of compute resources because we're transcoding a new release of a TV series, and then we're done after a period of time, and we can collapse that back down. So to make a comparison of magnitude, it's really hard because it's so elastic.
So I can sort of think of CDN as like the data plane for viewing network?
Absolutely, absolutely. It's a good way to look at it.
Big video cache.
Yep. We're just a big web server, really. That sure.
Just do that to Frank Underwood.
No spoilers. No spoilers. I don't
Any
know
other
if everyone's
questions?
watched it yet.
100 gigabit and above, what kind of transport do you see going forward? So transport meaning equivalent of TCP or RDMA or some other proprietary version. How do you see the end-to-end
Yeah.
figure?
So we probably have slightly different answers. Today I said we have 90+% market share of adapters that are greater than 10 gig. That's being driven by the hyperscale guys that were the first to adopt 40 gig Ethernet. Almost all of that's 40 gig today. 25, 50, and 100 are just taking off in terms of volume. Most of those vendors are consuming our Ethernet devices because of a technology called RoCE. I talked about it in an earlier session. It's called RDMA over Converged Ethernet. It's reliable transport that doesn't use the CPU. Microsoft showed that they were able to get that 100 gigabits per second on a single server with RoCE. And when they turned RoCE off, they only got half the throughput. They got about 50 gigabits per second. And the reason is they consumed all the CPU cores running software protocol stacks. So from our perspective, there's a lot of benefits to running RoCE. If you're going across the internet and you're not in a data center, then all of a sudden you need to start thinking about TCP/IP because of congestion management. There's some magic happening there as well. There's a thing called ECN, which is explicit congestion notification. We co-wrote a paper with Microsoft last year at SIGGRAPH. And so there's some interesting things that TCP is going to get a lot smarter. So you're going to stop dropping packets as a way of congestion notification. We're going to tell the network early that, hey, we're going to experience I always liken it to rear-ending somebody to figure out that there's traffic on the highway. It's better to use brake lights. So I think we're out of time, but thank you very much.